Hi, everyone. Welcome and thanks for joining us. We have a really exciting webinar planned for you today. We're joined by CyCognito's co-founders, Rob, our CEO, and Dima, our CTO, who are going to walk you through our new capability, continuous AI pen testing. Please put any questions you have into the Q&A box, and we will make sure to get to them at the end of the session. Rob, over to you.
Thank you, and it's great to be here and do this. We've been looking forward to this for a while, and we're excited to share with you what we've been working on over the last few months and some of the super cool things we get to do these days with our customers and many others now. So first, for those who don't know CyCognito, CyCognito is one of the leaders in attack surface management, and specifically many CSS, the #1 leader in external attack surface management. In our background, for those who don't know, Dima and I and some of our team members personally, we started our careers actually on the intelligence agency side. Many of us spent years in what some call reconnaissance in intelligence agencies, which is really about finding that path of least resistance into relevant stuff. And we built CyCognito to help enterprises, many of the Global 2000 today. We can see some of them on the right-hand side, to understand, #1, how attackers see their attack surface, but more importantly, what are the few things that massively matter and make the path of least resistance. So we spent now between 8 and 9 years or so helping customers map in depth what assets they have exposed to the internet that attackers can actually interact with. And we also build autonomous security testing capabilities, deterministic ones, to detect real risk with evidence in a way that is almost as good as a pen test, call it. But security teams and security leaders have been sharing with us these couple of challenges, especially over the last 2 years, that made us in the last few months decide to focus on this area that we're about to discuss, of course. #1, validation and red teaming in general is just very hard, very expensive, whether you use a third-party external firm to do it, whether you are building your own red team, just takes a lot of time, which makes it expensive and therefore also not scalable and not a continuous thing at scale. And 6 months ago, slightly more perhaps, many folks started to build their own AI pen testing capabilities around Cloud Code or what have you. And there are also some net new vendors that are saying AI is awesome. Let's use AI for pen testing as well. And interestingly enough, quite quickly you can get to a very impressive results in AI pen testing. The challenge, however, as many of you probably know, is #1, accuracy, but #2, cost and scale. It costs thousands of dollars per asset with these vendors to test, a single asset. But when you have thousands, not to mention millions of assets, and especially if you want to continuously monitor and test, ideally, everything, that's 2 orders of magnitude away from what you need to solve this problem. For some quick context on why this matters 10 times more today than it did a few years ago, #1, and I think you're all familiar with this concept, but the numbers are pretty staggering. #1, the shadow AI is just going nuts. Everyone is now building software, even people in finance and HR, and everyone is now a developer. But LLMs, AI, is not deterministic. So you can tell the AI, don't let my employees do X, Y, and Z. but Claude or what have you will not be able to deterministically and thoroughly enough guardrail them. So we see actually at CyCognito that a ton of the most egregious exposures, we'll see a couple in a few minutes, are related to MCPs and AI applications, AI resources today. We're also seeing that standard engineers are creating a few times more code. Not everyone is reviewing all of that code, as we know. And attackers are not idiots either. They've also discovered AI, and it now takes exponentially less time to create new exploits, run them, and now essentially like my mom, who's not very technical person, can, and she does, building websites, and now even a non-technical person can also pen test or try to breach stuff. So now many risk leaders are saying, God damn it, now with Mythos and what's coming next, truly every proactive creative attacker can run attacks that were rare and very sophisticated 10 years ago. Now they're super easy to run and take 15 or 20 minutes. For example, you can take over dangling domains within 2 minutes with Claude Code, which used to take maybe for a non-technical person a few hours or a few days, maybe, a year or two ago. So to summarize some of the things we've been hearing lately, and then we'll get to the truly fun part. But to summarize, to capture that, on the one side, when we look at CISOs and executives, it's really about, we know we have thousands and millions of assets. We know we've been pen testing or red teaming just 50, 100, 200 of them. We have to solve that now with AI, especially. We know that attackers can target anything at all. So that's the main notion we're hearing from, call it CISOs and risk leaders. Red teamers are mostly saying, look, even with Mythos, when we built at this services firm, for example, they built AI pen testing with Mythos, but they told us we're getting 30% false positives, and it's so expensive, it cannot cover more than a few assets per environment, not production possible. So it's about accuracy, and the most common statement we hear from them is, we want to test the right things at the right time, because they understand that the attack surface is constantly changing as well. So when we look at, okay, the challenge part here is pretty clear, and I think everyone is experiencing it one way or the other. So now let's look at, okay, what is the industry doing today? And the answer is, pretty much everyone in AI pen testing today decided to tackle this problem by focusing on the last mile part as the only part, in a sense. So let's take the legacy approach of picking 10 or 50 or 100 IPs and URLs, and then ask Mythos or Claude Code or something else, this open source or this vendor, to pen test it and hope that it will perform better than manual pen tests. But that's the common approach right now. And what we're saying is, look, that's exactly why it costs thousands of dollars per asset, per test. And that's why it's not scalable, not continuous, and lacks the context of the whole attack surface. So from our perspective, and from a mission perspective, we've been focused on this since day one. For us, this is a last mile problem of exposure management, simply. So we said, you must have deep attack surface context. For example, if I know about this IP, but I don't understand there is an MCP server over there, I'm not going to pen test perhaps that MCP. I will not be able to prioritize that, even if I massively care about MCP security and I want to pen test MCPs, but I'm simply unaware. And the least well understood aspect is the importance of running good enough testing on all the assets to help pick what makes the best targets. So you want to drive active testing on every single asset that has good evidence, good confidence rate that matters. And then you want to run AI pen testing that leverages all of these contexts to drive better accuracy and 100 times literally better efficiency, which translates economically to 100 times larger scale.
Yeah, I would add, I would say it's like, in a way, it's, I look at it as, I know, like everybody building those great engines, right? But kind of instead of a car, you're putting it on a wheel cart, right? So it's great to have a strong AI pen testing capabilities, but if you, like Rob said, just testing it on a handful of assets or just prioritizing things you already are aware of, it's not really, and kind of one size fit all configuration. Yeah, but we'll get to that.
Agree. Now, to make this tangible, this pyramid thing is the concept, but what does it really mean? Why does it make or not make sense? So let's just compare head to head. When you're running pure AI pen testing, which is how it's done today, well, first you need to manually, you need to solve the problem of picking the 10 or 50 or 100 things that are going to be pen tested, just like 20 years ago. So that critical part doesn't change at all, which is relevant to Dima's analogy. Then you burn tokens on just understanding what is this website, what is this IP, what's deployed there. Then you spend a lot of tokens on running all of these scanners. So these AI pen testing tools, whether that's a vendor or open source, would use, say, 30 different open source tools or common tools to detect potential issues. That's a job that in general, you don't want an LLM to do. There's no real benefit, at least 90% of it, you don't want LLM to manage the scanners. And only then you get to the interesting and truly valuable part of exploitation that requires creativity. That's where you definitely want to make your token spend. The other way of doing it is, number one, leveraging deep attack surface context, like where are my most attractive assets to attackers? Do I have MCPs exposed to the internet? Do I have unlocked doors exposed to the internet that attackers are very likely to find and try to exploit? Let's start there, right? Then I want to understand, what are these things? What's deployed there? What can attackers find? Then on the testing side, we spent a few years on building more than 100,000 deterministic testing modules that we run daily, fully automatically, obviously, on the hundreds of millions of assets or so that we cover every day to detect things like not only that you have this service exposed, but it's actually exploitable, and we have the evidence for it. And then we feed our AI pen testing engine all of these contexts. So number one, in terms of accuracy, we get much, much more accurate results. Number two, the efficiency so far seems to be about 100 times better, which allows for, call it 100 times better scale, which is the difference literally between 1% or really 0.1% coverage to covering the whole attack surface. Now let's make this even more tangible, which is the most fun part, and talk about, okay, why does this matter? What does it look like? What can this do for me, right? That's the only thing that matters as a start. So let's take a couple of examples here. The first, which is now super common, unfortunately, out there for enterprises, is a case where there was an MCP that someone creative decided to deploy, and it used this company's Salesforce data to provide whatever this MCP was supposed to provide. But the security team was not fully aware of this MCP's existence. And even though this huge enterprise is spending millions of dollars every year on pen testing and red teaming and AI pen testing vendors, this was not found until we found it, I think, on the first day of working with them on this. So let's break it down. First, our EASM platform found the existence of this MCP. You have to start there. And it even found that it doesn't have authentication to some of its capabilities. Extremely valuable finding, but that's where our EASM specifically stops. Then our AI pen testing came in, and number one, enumerated the tools available, enumerated what each tool does, the kind of data that is exposed, and whether that's a production environment or not. The bottom line is that you had tens of thousands of opportunity objects, many, many billions of dollars worth of opportunities on this Salesforce instance, completely exposed. And once you know you need to target this asset, by the way, this is relatively easy to exploit. The challenge is in figuring out that this is in reality, a crown jewel that would have never been picked, and indeed was not picked for any of the pen testing, red teaming, AI pen testing initiatives and programs at this company. Another example from another very large enterprise. So funnily enough, or what have you, in this case, the go-to-market organization at this big public company built AI risk management application to assess customer contracts for business risk. Makes a lot of sense. What makes less sense, but is extremely common, which is what we're talking about, is the security team was not fully aware or was not paying enough attention to what's going on here. And in this case, this is also an attack chain that is hard to find. The previous one, most of the value or weight is in figuring out to have an MCP with no authentication and then understanding what it means. Here, the exploitation is actually hard. So what our EASM did as a start was finding the application, finding that it has certain API endpoints exposed to the internet, which, for example, EASMs that are really port scanners don't do effectively. But then the AI pen testing came in and found a way to expose credentials based on certain error messages that the application would emit in certain probing situations. It then fully autonomously figured out how to leverage these credentials to create a net new admin user. Then it was able fully autonomously to understand what an admin user can do, which included reading all the documents on this application and even uploading documents, changing documents, and deleting documents. And it indeed even uploaded a new document to prove that fully autonomously. So this is a great example of something that could have taken weeks to pen test manually and to find if this was a key target, one of the 10 or 100 things that you would pick out of these guys have hundreds of thousands of assets exposed to the internet, for example. So again, problem is pen testing, AI pen testing, red teaming from a scale perspective would never get to even do anything on these kind of assets where what security teams and risk leaders now realize is where most of the risk is. It's not in the front door. It's not in the front door where you put all of your logs and invest most of your budget. It's in these windows and door in the back that don't get enough attention, and that now with AI, random people in the enterprise can randomly create or change. So we talk about scale. This is a fun visual way to illustrate the difference also in scale between going super deep on the 10 or 50 or 100 applications / IPs with pen testing and red teaming, as opposed to, making decisions every day on what's most important to pen test or test or red team today, and also in what way. You don't have to waste all the tools, all the capabilities on every single asset, even when you do target it. There are smarter ways to do it. And as anyone who's using AI already knows, context is everything in AI. So it's really about, you want to know where everything is, you want to test it continuously, you want to pick these right things and then target and try to exploit them. And when we talk about architecture, how do you actually get this done? And this also answers, hey, I'm hearing about these open source tools, I'm hearing about these few vendors. This sounds great, but help me understand, how is this really different? How is your architecture, your technology different from these 5 other things I and my colleagues heard of? So I would pay attention to a couple of areas here. One, we already mentioned the exposure assessment, or EASM, if you will, portion, and the huge power of having 100,000 deterministic modules that test all the assets every day and already detect a ton and a huge chunk of the potential and also verified vulnerabilities and exploitable things before the AI even comes into play. So we already covered that. The other huge part that Dima will double click on in a second is the following. It's the target graph, which is our AI layer on top of the left-hand side that helps us understand what are these things and what makes the best and most important pen testing, red teaming targets every day, and how they should be pen tested and exploited. And secondly, we talked about this element of decision-making on targets. And there is security aspects to it. There is economic aspects to it, because you have a certain budget, right? Whether that's $50K, $100K, $2 million, you have a certain budget. And the question is, what's the best way to utilize whatever budget you have? $10,000 if you're a small company, whatever. What's the best way to use that budget over the year, but also right now, today, based on up-to-date data. So Dima will hit that in a second. The last thing I'll quickly mention is deterministic validation. So if you use LLMs for pen testing, whether you've built it, someone else, a vendor, accuracy is going to be a huge challenge, even with Mythos and this grade of models. And what you want to have is both a lot of context, but also then deterministic validation that will take whatever the AI suggests it sees, even if it takes it a few rounds to come up with the final conclusions, and then say, okay, thank you, AI engine, and then test it in deterministic, specific ways that post a lot of research you've done that tell you for sure, okay, I know this exists. I know this is real. I know it's exploitable. Here's the exact evidence. So Dima, why don't you take the lead on double clicking on a couple of these components, what they do, why they're completely different from the common approach today.
Yeah, sure. Thank you. So, yeah, so as Rob said, it like kind of our journey starts almost a decade ago, and we've built all this like complicated and very large scale discovery and contextualization system that can run on the biggest enterprises in the world, and um, and basically now we can leverage that for choosing what we want to what we suggest to test. And so this is a unique part to what we do. Basically, this component looks at all the data we have, and especially it's an important point, the testing part, the non-pen testing part, which is completely deterministic, very large scale, very efficient, battle tested, and we can take all that and produce some kind of score, right? And then it's some number that says like how much we think this asset should be tested. For those who are familiar with us, we have the security score, which quantifies how much risk does this asset possess, or this website or what have you. But this one is a different one. It's like how much we think it should be tested. And I think from what we know, we are the only ones who even approach this problem from that perspective. And it is like a number in the end, but it's based on a lot of different signals. And this is another important part, because the way we operate is we start from the organization name, basically the main website, or just the name, and do all the hard work automatically and by ourselves. It's a complete black box solution. So we have all this rich context of about everything that we find, and we can have one signal that we are having is what the situation of this asset is, like how is the security situation. Like we ran all those tests. We know how to detect WAFs and other security protection components, and we can assess that, okay, this asset looks shady, right, or funky. There's some outdated software on it. There is an XSS. There is something, quite a lot of interesting findings even before the AI pen testing. And we can then extrapolate that. This is already more sophisticated stuff. We can extrapolate that and think, okay, those parameters feel like there might be more, right? Things like that, so that can help us prioritize. So that's one way to look at prioritization, basically, for testing. The other way, which is extremely important from our perspective and kind of takes us back to intelligence agencies and all that, is the attacker perspective. So because we start basically like an attacker with just the company name, we have all this paper trail, right? So we can also explain everything. That's another important point, as I'll touch in a second. But we can also kind of simulate the attacker perspective. We know what is more exposed, what is less exposed, what is easier to find. We know that attackers, and doesn't matter if it's a state level or some opportunistic person, they usually start from the more exposed, more reachable things, a context usually security teams lack. And in addition to that, we can also say that okay, this week today, right? There was some big security 0 day or some emergent issue, and um, we want to react to that immediately. That's what Rob was saying about like this daily or almost real-time kind of feeds. You don't want to wait for the next pen testing round. We know that the attackers are now looking for those specific tech stacks or technologies, and they might, and we want to immediately test that. So we take all that into account. It's not just one type of signal, it's intelligence and security posture and testing and everything on all the attack surface.
Yeah. I will quickly add that, number one, to Dima's point, the attack surface is a live and breathing thing. We all understand that. I think we all agree. But that's just not how these kind of processes actually work today, in at least the vast majority of the enterprises. But if you take a step back and you look at all of these concepts, I would say that every CISO I talk to, 9 out of 10 would say, this is like, how do you prioritize risk? What's critical? Oh, it's things that are, what's a critical vulnerability? It's things that are exposed to attackers that are truly exploitable. And of course, if they are fully exploitable, no question. Of course, that's critical. But you then ask folks, okay, is that how you prioritize risk today? Is that how your workflows work today? And the answer is almost always no. We're now figuring out how do we take CVSS, which we're using today, and we use some threat intelligence or something like that to slightly improve it. There is 2 or 3 orders of magnitude of improvement, for example, on the vulnerability management side to be relevant. Large enterprises, when you have thousands of criticals or alleged criticals, not to mention tens of thousands and sometimes more, is that relevant at all? So more and more risk leaders are saying, you know what? I don't care anymore about CVEs. I don't care anymore about IPs. Don't talk to me about that. Only talk to me about the few exploitable things that are also ideally relevant to what my threat actors are doing right now, and the assets and data that I have out there. And Dima, you created here a couple of helpful examples.
Yeah. So, and it's a very good clarification, because it's not obvious. Like that's not how the market usually works today. And here is an example of kind of our approach to this kind of target scoring, targets graph. We can score something high even if it has no issues. We didn't find any kind of deterministically any issues, but we know that it's a very kind of juicy target for attackers or extremely important thing, or that we have active campaigns. We know there are active campaigns that target those kind of technologies or assets right now, and we can react immediately. On the other hand, if it's like something, just some micro marketing microsite, it's probably less interesting, still interesting, but to a lesser extent. Yeah.
And by the way that the vulnerability management tools and attack surface management tools by and large work today is, if you have the same CVE on 2 assets, one is your literally Salesforce data set, and the other is a completely redundant random server, it will prioritize them exactly the same way. So it's both about the asset business context and, of course, true exploitability.
Yeah. Yeah, totally. And here is an example of actually of kind of reacting, right? Because you have some portal when we are watching it, it's not very highly scored, but suddenly that exactly is the example I was talking about, like a new critical CV was found on this kind of devices. So first of all, our automatic testing immediately will test it kind of deterministically, but also we will bubble it up and suggest it to you to test, right? So it's a reactive system. It's kind of reactive proactive system. We don't wait for the monthly or quarterly testing. It just immediately, and that's part of the efficiency because you don't need to constantly test. You need to test at the right moment. If the asset doesn't change much, you don't need. So it's all the economics here is extremely important.
Yep.
Yeah.
But also, I would say, if you have these MCP, API, whatever, exposed for 2 weeks, right? So you're planning the annual red teaming, pen testing, what have you, in July. Then in August, this thing pops up. Maybe it disappears later. The plans ideally are aligned with the attack surface on a daily or better cadence. So yes, that the cadence aspect and the live view of what's going on massively matters in that regard.
Yeah. Yeah, totally. And kind of to sum it up, so it's not our general approach kind of from both product and engineering perspective, how we build the system is not one size fit all. Not like let's do everything the same way. Different roles, different things need different approaches, and we can embrace that. And we embrace this kind of mixing those together. So just to kind of sum up like how this whole thing works, we have the target graph, which suggests assets. We have the planner, which is kind of this something between the CFO and the operations person that decides what is actually the plan. The plan is based on the scores and the scope that the user provided, and like goals and all this context we already, because it doesn't need to be one size fit all with testing as well. We can do wide and shallow pen testing, and then kind of do it more focused on fewer assets, kind of zoom in on the something that I'm not sure that is happening today, because it just needs very large scale. And another important point is the contrarian here. This was Rob was mentioning. You need to pad AI with kind of non-AI stuff around. So we see it as like we need both critical AIs that look at the results, but also deterministic stuff. Validating, a lot of times validating is easier than finding, right? Like finding the solution needs the security issue, like the exploiting needs a lot of creativity, which AIs are great at. But validating, you don't always need an AI. You can do it a different way. So it's an important point. It's not, AI is a tool, right? A great tool. But we have this kind of mix and separation into different components. Obviously, we report the results, but that's basically how kind of we look at this challenge.
And if you look at the levels, one easy way to think about, okay, AI pen testing sounds great, but I have different kinds of assets, right? Some are super sensitive production systems. Some I'm fine with like deeply aggressively testing. How should they think about that? So this will be very helpful for it. So first, and also in terms of time frames. We have today our EASM and autonomous security testing, which work at full scale, daily, test everything, where AST is active testing, deterministic active testing, that is completely safe and therefore does not require any specific approvals or review of users on, is this safe, should I do this? Okay. Then there is the tier one, we call it, of exposure validation. So this is like AI-powered deep reconnaissance. It would do things like finding more exposed resources. If there's no authentication and things like that on this asset, it will investigate what's behind this door. And so it will find much more risk, a lot of evidence around it, but it's not exploiting things yet. Then there is tier two of safe exploitation. Here we're actually using exploits to, for example, literally deploy this web shell on this server and communicate back to prove that, yes, we were able to achieve admin or system privileges, and this is a completely exploitable asset. You have to do XYZ right now. Here's all the evidence. Advanced exploitation takes this one level beyond when you're exploiting certain logic flaws in applications. For example, it's sometimes hard to know what's going to happen exactly. So these happen with alignment with the user and with the user approval of, hey, we were able to achieve X, Y, and Z with tier one and tier two testing. This is exploitable, and here's what we found. And here are a few more things that we can do right now, if you like, to prove that this vulnerability or attack chain is completely exploitable, or we were able to become an admin over here. It seems like we can also do X, Y, and Z more. It's up to you. We can do it for you. You can take this script and run it yourself or adjust it. So that's the top tier testing. And I would say the good news is a huge chunk of the value, we are still learning more. Potentially, it's the vast majority of the value is actually in tier one and tier two, especially at scale. Also, among other reasons, because that's what attackers actually do 99% of the time. And because we have a bunch of questions here from the audience, which is great, we'll turn to Q&A in a minute. But just before and to wrap up, I'll mention or summarize that. Number one, we talked about scale, right? Every capability, even if it's perfect, even if it's free and perfect, which doesn't exist, obviously, but if it only covers 1% of my stuff, I should ask myself, is 1% coverage good enough, even if it's perfect? And the answer seems to be absolutely not. Number two, the question of economics. If a single test costs me thousands of dollars, whether that's a homegrown thing my team built or some vendor, if it's thousands of dollars for a single test, can that scale for me? Is that going to work for me? And then there is the question of accuracy and trust. Can I trust something like an homegrown AI pen testing tool that, no one really read the code that was built there, or anything that produces a lot of false positives, the bottom line, is not going to be good enough, especially not at scale. So I recommend and welcome you to challenge your colleagues and to think critically or also with your vendors on, hey, we have thousands of applications or tens of thousands, millions of assets in our attack surface. What percentage of them can you help us test and make sure are secure? And if you're helping me cover this 1%, or in other contexts, 50%, how can you help me make sure the other 50%, or really 99%, is not going to kill me? So with that, and we have, by the way, this QR code if you want to learn more and see it with your own eyes on your own attack surface and assets, which we would love to. We do have a long list of questions here, which is great and fun. So with that, let's move to them.
Great. Thank you so much, Rob and Dima. Yes, let's get into the Q&A session. Okay, let's start with this one. Would AI pen testing validate exploitability, including detecting an exposure? Would this be limited to external attack surface, or would this attempt to pivot into trusted zones?
Beautiful. So absolutely yes. Each attack chain consists of very deep evidence, like literally, here is the web shell we were able to deploy in this directory in this way, and here is the who am I commands, what have you, we were able to run that show that we now have system privileges. And by the way, we are seeing these two internal NICs inside your network, which also means that your firewall or what have you is potentially not working properly, which is another potential concern, which is also a segue to the second question here on external versus internal. So historically, CyCognito always focused on outside in. That's where 80% of the attacks come from. And it's also our special expertise. So that also is relevant and true for our AI pen testing. Now, we're already seeing that this leads us into internal networks, and our customers would love to see the lateral movement continuing there. So we absolutely plan to do so, but we'll probably not be there, definitely not in the next couple of quarters. We do plan to get there, and it's something we are now discussing with some of our design partners. I can share.
Would help if I wasn't muted. Another question that's come in says, if I have 3,000 websites, like one of the slides says, what would you actually tell me concretely about how many get tested and how often?
That's also a great question. So our EASM and AST, I'll put it this way actually. Our AST, Autonomous Security Testing, includes DAST, Dynamic Application Security Testing, and other things. So these will test all of the 3,000 applications, even on a daily basis. If you want, that's up to your subscription. But our pricing is also super scalable, and we charge based on value. And so I can share that 99% of our customers, pretty much all of CyCognito customers, are testing all of their attack surface with these capabilities. So that's number one. Number two, as I think we mentioned on one of the slides, we economically, the current plan is to propose that by default we will AI pen test 5% of the assets, and we'll cover some of the assets a few times a year, so that the bottom line would be that every asset is tested at least once a year at some level, even with AI pen testing. But we will drive the deep pen testing that costs exponentially more on a smaller amount of the assets that would still be, call it 100 times more than what you can get in any other way. But that's how we are currently planning to make the default distribution. You will be able to completely reconfigure that. So you could say, look, I have 100K budget for AI pen testing or pen testing. I only want to deeply pen test stuff. In general, it doesn't make sense, but let's assume that's your decision. So yes, the platform will allow you to only super deeply pen test a much smaller portion of the attack surface, but it's probably not smart. You probably want to distribute that so you cover everything that matters and you deep dive where it matters.
Yeah, it's a sliding scale. Like that's how we look at it. It's in a way to say more technically, it's an optimization problem, resource optimization problem, where you have control over the kind of the algorithm.
Yeah, and what's unique about our approach, at least today for sure, is that we're not telling you it's your problem. You pick 100 things and we will test just them. We are doing all of the heavy lifting and data crunching to make it super easy to drive, to the point that by default, maybe you'll want to completely autopilot this. Like, here's my budget, go ahead, you'll find a lot of stuff, super valuable, great, easy life. You can also just use that approach.
Okay, great. Another one for you. Is this meant to replace our existing manual or human pen test vendor or run alongside it?
Also a very good question. I would say that the way most folks think about it is they're currently spending in most enterprises between 50K and $500,000. Some spend millions too on external pen testing services, which you have different flavors of, and some large enterprises have 5 or 10 vendors for such services. So most enterprises and most risk leaders we work with are thinking about replacing mostly those dollars and some software dollars to leverage our AI pen testing. In terms of internal red teaming, we by and large don't replace that. You probably want to leverage our platform to test everything at scale, and then have ideally at least a few people that, number one, can go very deeply where humans are still needed for sure, and maybe that will be the case even in a year or two, who knows, right? But in general, absolutely, you want the team to run deep assessments, especially inside the network or around very sensitive things. But these are two like yin and yang approaches, right? You want the huge scale, super efficient engine, and then you want the smaller scale, sensitive, smart company and like human context aware red team to do their thing. So that's how at least 9 out of 10 maybe leaders we talk to see.
Okay. And also, how much control do we have over the testing, and what type of destructive testing validation do you have?
That's a super important aspect. We talked about it a little bit. I'll share this slide again for a second. We talked about this here. So this slide will be helpful. So the first control that you have, and I'm glad this was brought up, the first control that you have is that the platform will ask you what assets you approve to be in any kind of AI pen testing scope. So even the super safe tier 1 stuff will not be done on assets that are not in the AI pen testing scope. And then each tier, and especially 1 and 2, but let's call it every tier, also has to be approved, both in general and regarding group of assets. So for example, you can say tier 1, extremely safe, do it everywhere, great. Creating a lot of value, super simple, autopilot, great. Safe exploitation, I want that everywhere too, except these 10 or 15 production assets. Excellent. Then tier 3, that can only be approved per test, per asset, because it's sensitive. And that replaces, phone calls and emails with this pen testing firm. So now you'll have that through UI with all of the context of, here's what we can do, here's what we found so far, here's the next step that is possible, and here's what it's going to do, and our assessment on the level of risk. Of course, you own the asset, you have the inside out perspective, which is always better and more accurate than outside in only on these kind of things. So that's why tier 3 is per asset, per test. So that's the big picture on how you, I think you could say, fully control every aspect of what's in scope and how it's getting pen tested.
Okay, great. I think that's all we have time for. So I just want to thank you so much. Thank you, Rob. Thank you, Dima. Thank you all for joining us. We will be sending this recording on to you as well, so look out for that. And I hope you all have a really great rest of your day. Thank you so much. Goodbye.
Bye.
Thank you, everyone.
Thank you.